Hello my dear students, welcome back to NEET World. So in this session, we will be discussing aldehydes, ketones, carboxylic acid. So this is our session 1 on this aldehydes, ketones, carboxylic acid for NEET, JEE and EAPCET. Okay? Yes. So in the last sessions, we have covered up to alcohols, phenols, ethers. Okay? We clearly discussed all the important topics from those chapter, and the next we have solved some very important PYQs related to those chapter. We have almost like dedicated a session, a live session only for problems of alcohols, phenols, ethers right now. So we have extracted some questions like PYQ questions of NEET, JEE and EAPCET, and we have solved. I hope you watched those sessions. If not, just after completing this, you just go and watch it because it's highly helpful for your preparation. Okay, right. So in this session, here we have, let's have a basic idea, basic introduction first, and then we'll go to one by one very deeply. Okay, right. First of all, let's know about their importance, then we'll go for the UPSC nomenclature and all. Okay, see, where do we see this aldehydes? Yes, aldehydes, ketones, we have many applications in our daily life. For example, you might be much familiar with ice cream right now. Vanilla is one of the flavors of this ice cream, right? Right. So now it contains aldehyde as a functional group. What is the functional group present in this vanillin ice cream? So it is aldehyde. So you can just see here, aldehydes and ketones plays an important role in biochemical processes of life. Okay. So they add fragrance and flavors to nature. For example, vanillin from vanilla beans, and salicylaldehyde, okay, so that is from these sweet meadows. Okay, cinnamaldehyde, this is from cinnamones. Okay, yeah, these are some daily life usage compounds we are discussing here. The next, so they are used in many food products. Okay, so like pharmaceutical industry also, it has very good applications. Okay, right. So it will play one very crucial role in synthetic organic chemistry. Okay, right. So let's move forward. Here, what will be the aldehyde, like IUPAC nomenclature and common names for this aldehydes. See, when we are writing for aldehydes, see how we are writing. For example, the simplest aldehyde possible is, see, why we are calling these aldehydes, ketones as carbonyl groups? Because they have C double bond O as a functional group like this. Okay, and specifically when we are seeing aldehydes, this carbonyl group, this C double bond O is there now. So this carbon should have one hydrogen. Okay, so this is the functional group indication for aldehydes. Okay, so this is a functional group. Here it might be any alkyl or aryl group attached this side. Okay, but one side of this carbonyl carbon should contain a hydrogen. Then we can consider it as an aldehyde. Okay, so whenever there is an aldehyde like this, as per the IUPAC nomenclature, if we are counting this aldehyde carbon also into the chain, we should end the name of that compound as Al. So what is the suffix? Al, al. Okay, for example, here you can see what I am writing. Like this I am indicating. Now count the number of carbons, 1, 2, 3. Okay, 3 carbons are there, means prop, and this is alkene or alkane, it's a simple alkane now. So propane, so at first position we have double bond O, propanol, like this, propanol. Okay, so now this is how you need to write the IUPAC nomenclature for aldehydes. Okay, so let us take, okay, so let us take ketones also here itself. See, whenever I am saying ketones, it should have a carbonyl group like this. Okay, to this carbonyl group carbon, there should be carbons directly attached here and here. Both sides should be carbons. Then we can say it as a ketone. Okay, so now what this R indicates, any alkyl group, here it is attached like methyl group, like that. If both sides we have only methyls, what we can call it as? This name of this compound is acetone. What is the name of this compound? Acetone. Okay, this is a common name of this compound. Acetone is a common name. Yeah, but remembering these common names is very difficult because there are a lot of common names, like for different compounds different names are there, so it's very difficult to remember all those common names. That's why we are using IUPAC names. Now tell me, how can you write IUPAC name for this compound? It's very simple. See, you just start numbering from any of this carbon side because both of them are same here. So 1, 2, 3 we are writing. So 3 carbons means prop right now, but at second carbon we have keto, like carbonyl group. So you can say propanone, propanone. So the suffix for ketones will be one, on. Okay, so its position is 2. So propane 2-on, or simply you can write propanone, because ketone, what is the condition for a functional group to be a ketone? The carbonyl group should contain both sides alkyls groups only, like methyls, ethyls, like that only. Both sides alkyl groups only. So you can simply write it as a propane 2-on or propanone also, perfect. Okay, right. So hope the discussion is clear. Right. Now let us write few more things here. What is the IUPAC name of this compound? Because in the last class we have discussed about alcohols. Now in this class we are discussing about aldehydes. So tell me, how can we write a name of the compound having alcoholic and aldehydic functional group? I hope you have watched my IUPAC nomenclature session where I covered clearly how to give the IUPAC name of a compound having polyfunctional group, okay, multiple functional group. Just tell me, how can we answer this? Yes, you can try that. Yeah, so you can write the name in this way. See what I am doing, based on these two functional group priorities, we need to number the carbons. Okay, now here this is a carbon, 4 carbons are there. So you should start numbering from aldehydic functional group, because this is the principal functional group, right? So 1, 2, 3, 4, like this. Okay, at third position hydroxy, so 3 hydroxy butanol. That's it. This is the name of this IUPAC name of this compound. Okay, right. Now if same thing is there, so tell me, how can you write the name of this compound? Yeah, how do you number this again? So here we have hydroxy group, here it is a ketone. So ketone means which is priority? Again ketones are priority than hydroxy groups, alcohols. Okay, so if you are writing alcohol as a suffix, it should be ol, alcohol. Okay, ol. Okay, for aldehydes it is al. Okay, and if OH is a prefix, not suffix, here it is a prefix now, because this is the principal functional group. If one is considered to be principal functional group, whatever the functional group present other than that, all of them are considered to be prefixes only. Only our principal functional group becomes suffix, remaining all other functional group becomes prefixes only. Now whenever you are writing those in the prefix, you should follow alphabetical order. Okay, so let me tell you one example here. Here we have OH, right? So here I am writing NH2. Now tell me, how can we write the IUPAC nomenclature for this? Right. So start numbering from this terminal, because our principal functional group should get a minimal number. Okay. So 1, 2, 3, 4, 5, 6. Okay. Now tell me, what is the IUPAC name for this? Okay. So 5 hydroxy or 4 amino. Which comes first? Amino comes first now. So A comes first now in alphabetical order, because these are two other functional groups. This is principal, these are subsidiary. So it means this should be indicated as a prefixes only. While writing prefix, follow alphabetical order. So amine comes first. So 4 amino, 5 hydroxy, 5 hydroxy. So 6 carbon chain contains 6 carbons now. So hydroxy, hexane on. Okay, again we haven't indicated the position of this ketone now, so hexane 2-one, this is how you need to write the name, hexane 2-one. So yeah, this is how you need to write the IUPAC name of the given compound. Okay, is this clear guys, is this clear? Right, if the discussion is clear, let's move forward with few more examples and you just tell me what will be your answer for these compounds. Yeah, so this example I have explained when I am discussing IUPAC nomenclature. Tell me, how can you write this kind of compounds names? See, it's very simple. Here we have aldehyde, here also aldehyde, here also aldehyde. So if I prefer the parent chain as 1, 2, 3, 4, 5, so we cannot take it like this because this is also principal functional group only now. We should not ignore that. So in this case, you need to consider just a carbon sign by not considering these aldehyde groups, just consider 1, 2, 3. So propane is there now, so you can say propane at first position, second position, third position we have aldehyde now. So you simply write propane 1, 2, 3 tricarbaldehyde. So this is the IUPAC name of the given compound. Okay, is this clear? How can you write the names? Propane 1, 2, 3 tricarbaldehyde is a IUPAC name of this compound. Okay, is this clear guys? If the thing is clear, just click on the follow button and like button. If you are new to this channel, click on the follow button. Okay, right. So next, ketones are also over, right. So the next, let us understand the structure of this carbonyl groups. See, carbonyl group will be like C double bond O and 2 bonds. We know carbon valence is 4. Yes, there are 4 bonds. Okay, right. So now how many sigma bonds are there around the carbon? 1, 2, 3 sigma bonds. This is a pi bond consider. Okay, so there are only 3 sigma bonds now. If there is only 3 sigma bonds, hybridization becomes sp2. What is the hybridization of this carbon? sp2. If hybridization is sp2, we are going to get a trigonal planar. What I am saying, trigonal planar geometry. So this carbonyl group carbon is a planar. Okay, it's a planar one. Okay, so since it's a trigonal planar, I can indicate this trigonal planarity in this way. See, like a triangle with a plane. Okay, like a plane. Okay, so this is an sp2 carbon with trigonal planar geometry, remember. Right. So now if this is undergoing some reactions, see what type of reactions it can show. See, carbon is there, oxygen is attached. Between carbon and oxygen, who is electronegative? Oxygen, right? So this pi bond will be shifting towards oxygen side. If it is shifting towards oxygen, what happens? It creates partial positive charge on the carbon, right? It creates what? Create partial positive charge on the carbon. Why it is creating partial positive charge? Because pi electrons are taken only by oxygen, since it is more electronegative. Therefore, oxygen gets partial negative, carbonyl carbon gets partial positive. So it is becoming an electrophilic center. Right now, it is becoming an electrophilic center. Carbonyl carbon is becoming an electrophilic center. Okay, so electrophilic center it is. Okay, so when it is becoming electrophilic, now a nucleophile can come and attack on that electrophilic center easily. So I can say carbonyl groups undergoes nucleophilic addition reaction. What type of reaction it will show? Since the carbonyl groups are electrophilic, this nucleophile can attack on it. So I can say carbonyl groups undergo nucleophilic addition reactions. In a simple manner, I am writing nucleophilic addition reactions. So nucleophile means nucleus loving species. It has more electron density. That's why attacks on this electron deficient sites. Okay. So now what happens? You are going to get, see, it is becoming O minus one side, and this nucleophile is attacking on the carbon. You can write it like this. That's it. So a sp2 carbon is now converting into an sp3 carbon. Okay, a trigonal planar is becoming a tetrahedral geometry here. So it's a tetrahedral geometry. Okay, right. Now I will tell you little more discussion on this nucleophilic addition reaction in the chemical properties, but as of now you just remember the discussion that we did till now. Okay, now look at the physical properties it has. What are the physical properties it has? See, lower aldehydes like formaldehyde and acetaldehyde. What is the structure of formaldehyde? So you just write C double bond O hydrogen. So this is an aldehydic functional group now. So if both sides are hydrogens, then you should say it as a formaldehyde. Okay, you just remember it as a formaldehyde. Now acetaldehyde means you just write carbonyl group like aldehydic functional group with a one carbon like this. So methyl group is there, acetaldehyde. So what is the name, IUPAC name of this acetaldehyde? See, 1, 2. 2 carbons are there means ethanol. What is that? Ethanol. Al. Okay. So physical state, lower aldehydes are gases, whereas higher members are, it may be liquids or solids also. So these are gases and higher are liquids and gases. Okay. So now aldehydes show pleasant smell. Okay. So they will be having pleasant smell. Okay. And formaldehyde is having pungent, and here vanillin is having a fragrant smell. Okay. Remember this. Now boiling points. Higher than the boiling point of carbonyl groups will be now higher than the hydrocarbon. Why they are higher than the carbonyl hydrocarbons? Because carbonyl groups contain a polar bond here, C double bond O like this we have. Okay, whereas in hydrocarbon there is only carbon hydrogen bonds only, right now carbon hydrogen bonds only we are seeing. So these are less polar. When it comes to carbonyl group, they are more polar. So higher, so that's why boiling point of carbonyl groups is higher than the hydrocarbons due to dipole-dipole interactions. What is the interactions it has? Dipole-dipole interactions. Okay, right. So higher than the hydrocarbons, boiling point is higher than the hydrocarbons due to dipole-dipole interactions, and it is lower than the alcohols. The boiling point of aldehydes and ketones is lower than the alcohols, because if you see in alcohols, like if you write methanol and all, so how it will be? Yeah, so this bond is more polar because hydrogen is attached to oxygen now. Yeah, it is more polar, it becomes, therefore and it also forms hydrogen bonds with these alcohols. Okay, so between hydrogen molecules we can have hydrogen bonding between the molecules, but here in the carbonyl groups it is lacking. That's why the boiling point of alcohols is greater than aldehydes. Okay, so here you can see boiling point of alcohols is greater than aldehydes and ketones. See, so lower than the boiling point of aldehydes and ketones is lower than the respective alcohols because they lack in hydrogen bonding. Okay, that's it, remember. Now solubility, lower members soluble in water due to hydrogen bond, but solubility decreases with increase in alkyl chain. See, carbonyl groups, if these attached groups are small, then we can say it is having non-polar nature, less non-polar nature, and this using this oxygen lone pairs, it can form hydrogen bond with the hydrogen water molecule right now. But as we increase this alkyl group chains, size increases, what happens? Hydrophobic nature increases now. So due to that reason this solubility decreases. So lower members soluble in water due to hydrogen bond, but solubility decreases upon increasing the alkyl chain length. Okay, remember this. Next, so now these are readily soluble in organic solvents. So carbonyl groups are readily, compounds are readily soluble in organic solvents like benzene, ether, etc. Okay, remember this. Yeah, let's discuss a little more. Yeah, so now let us discuss about methods of preparation of carbonyl compounds. How can we prepare these carbonyl compounds? Okay, so first one is from alcohols. Okay, this is again very important. Already we discussed the chemical properties of alcohol. See, the chemical properties of alcohols are now preparation methods of aldehydes and ketones here we can say. Okay, not all chemical properties, but alcohols upon treating or undergoing oxidation gives respect to carbonyl compounds or carboxylic acids right now. So now let us say here we have primary alcohols. Okay, so upon oxidation gives either aldehydes or carboxylic acids. Okay, if I have secondary alcohols, oxidation gives ketones. What they will give? Ketones. Okay, and if there is a tertiary alcohol, no reaction. Actually, some oxidizing agents are there, no reaction. But sometimes it will be undergoing dehydration to give you a alkene product. Okay, so let's see this using a one small important table here. See, KMnO4 gives carboxylic acid. What it will be giving? Carboxylic acid. Let me write COOH. Okay, and here also it is COOH. When it comes to secondary alcohol, it will giving you ketone. Okay, all secondary alcohols will give you ketones only, whatever the reagent may be here. Okay, so ketone, 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 ketone. Okay, so K2Cr2O7, here it is carboxylic acid, here choline's reagent and pyridinium, yeah, so pyridinium chlorochromate is there, here it is aldehyde. Okay, Jones reagent again carboxylic acid, okay, and Cl2 it is aldehyde, and copper metal it is again aldehyde. Okay, right. When it comes to tertiary, it won't react. Tertiary alcohol will not get oxidizes with this oxidizing agent till here. Okay, but when we have copper metal under heating condition gives you one alkene. What it will be giving you? Alkene. Okay, undergoes dehydration to give you alkene. This tertiary alcohols converts into alkenes by dehydration using copper metal at 300 degrees Celsius. Okay, right. This is a table. You just take a screenshot of this table. It is really helpful for your preparation. Okay, right. Next, yeah. So the next method is from method of preparation. Next method is the hydrolysis of geminal dihalide. What do we mean by geminal? See, for example, here on same carbon, on only one carbon, if I have two halides, for example, here I am writing one halide, second halide like this. Like this we have. Now what happens upon hydrolysis of this compound, this X minus goes out, halide ion goes out, here also halide ion goes out, into that this OH group of water comes in. Okay, so that you will get CH3, CH, OH, OH. One of the very important reaction now this is. Okay, right. So generally it is given as aqueous KOH or NaOH, like this they will mention. So now what is happening? This halide ion is going out and OH minus is entering in. So it's a nucleophilic substitution. One is going, another nucleophile is coming. Okay, so this is a nucleophilic substitution. Now the important thing to remember here is, if on same carbon multiple alcohols, hydroxy groups are present, there will be some repulsions between the lone pair electrons of these two oxygen atoms. Okay, so due to that repulsion, geminal dihalide alcohols are less stable. So now what happens? They will undergo dehydration. It means elimination of water. See how I am eliminating? See this OH and this H, removing as water. So if I remove it as water, what is the remaining thing? CH3, CH, this oxygen is there, double bond O. Okay, so we got our aldehyde as a product here. Aldehyde as a product. Okay, hope the discussion is clear. Okay, is this clear or not? Clear now? Right. Next. Sir, you are only saying about geminal dihalides. Why? What happens if we have monohalide, dihalide, trihalide? Let us take all those and let us see the difference. See here R, CH2, Cl I am taking. This is monohalogen. R, CH2, Cl, Cl, this is dihalogen, and next one I am taking a trihalide here, R, CH, CH, Cl, 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 okay. Yeah, so now let us do base hydrolysis here, treated with aqueous KOH. Now what happens, whenever you are seeing aqueous medium, so substitution takes place. So this chloride ion will be substituted by OH, so that we will get RCH2OH. Okay, simple alcohol is formed. Alkyl halide, monoalkyl halide giving an alcohol. But if I do a geminal halide hydrolysis, what we are going to get, both chlorides will be replaced by OH now, so that you will get RCHOH and OH. So this will undergoes dehydration, okay, hydrogen and OH, and gives you RCOH. An aldehyde is formed. Okay. Now what happens here? What happens here? All three chlorides can be substituted by OH groups, and we will get RCOH, OH, OH. Okay. The next what we can do? We can eliminate water. How can we eliminate water? Hydrogen, this one. Okay. Now one more OH is also there now. Yeah. So we cannot eliminate that as a water, because there is no other hydrogen to remove it as a water. Only OH group is there. So what we have here after eliminating water? So carbon, alkyl group carbon with one oxygen and one OH group. Yeah. Carboxylic acid is present. Okay. So you need to get that. If it is a geminal dihalide, we will get an aldehyde or ketone depending upon the group we are taking here. Okay. And if it is a like a trihalides, this is dihalide, this is geminal trihalides. If it is geminal trihalide, we are going to get a carboxylic acid. Remember the difference. Okay. So this difference is important to be understand here. Okay, right. Guys, if the discussion is clear, just click on the like button whatever we discussed. See, now one of the most repeated question in your exam is this one. So this is how the mentioned product is mentioned. Now what is the intermediate A formed during this transformation? Okay, what is the intermediate A formed during this transformation? This is the question they will ask. Now how can you get to know this A? See, what I told you, in order to get this product we required, see, this is an alcoholic KOH, it means like aqueous KOH. Aqueous KOH means substitution taking place. Okay, so now what you need to know here is, the product formed here is definitely a chloride, alkyl or aryl chloride here, whatever might be the product. Okay, but you need to identify A. How can we identify? See, chlorination in presence of sunlight, where it happens? It happens at this benzylic carbon by Friedel-Crafts, by free radical substitution reaction mechanism. Okay, so here just remove hydrogens and place with chlorine. Okay, if I only substitute one chlorine, we will get CH2Cl. But if I consider this as A, this is not our product, because only aqueous KOH means only one chlorine is replaced by OH group. Therefore, we will get a benzyl alcohol, that is alcohol, but I want aldehyde now. So for that purpose, what I need to do? I need to remove two hydrogens like this. If I remove two hydrogens, now what happens? Treat this with aqueous KOH. So this chlorine can get replaced by OH group, and this chlorine also get replaced by OH group. So that we will get a geminal diol. Geminal diol will get like this. Okay. Now from here to here, what we are doing? Just eliminating the water. Okay, eliminating this water. Okay, so gives you this final product. So what is our A here formed? A formed will be like this. A dihalide, geminal dihalide is formed. Okay, so this is how you need to identify the intermediate by looking at the product formed. Okay, I hope the discussion is clear. Okay, this is the JEE mains question previously asked. Okay, right. Even for NEET it is equally important. Yeah. So now ozonolysis of alkenes. Guys, if you have studied hydrocarbons, the hydrocarbon chapter will not be completed without knowing ozonolysis of alkenes, without knowing hydration of alkynes, okay, and other reactions I am going to show you now. So all these reactions are very important in hydrocarbon chapter itself. Now, if you haven't watched hydrocarbons and if you haven't got full clarity on hydrocarbons, just go to my playlist of this channel and you can watch my videos on hydrocarbons, okay. Clearly discussed these important reactions: hydrocarbons, ozonolysis, hydration, hydroboration, oxymercuration, demercuration. All these reactions are clearly explained. You just watch it, okay. Right. Right. So now listen here. What happens whenever you are taking an alkene like this? Like this, you just add ozone, okay, using zinc as a reducing agent, again water to be taken here, that's it, okay. Now what happens is ozonolysis, it means ozone will be breaking these alkenes into two equal halves, okay. You just break this double bond like this. Now this carbon, this alkene carbon converts into carbonyl group, yes, this is also converts into carbonyl group, okay. You just place carbon as it is. On that we have one hydrogen and one alkyl group is there, right, as it is, and this double bond, here you place one oxygen, that's it, okay. Place this side also same story, carbon, one alkyl group here, another alkyl group here, and insert one oxygen over here. So out of these three oxygens of ozone, one is given to this carbon, other one here, and one more oxygen is given to this zinc, okay. We will get a zinc oxide, okay, right. Okay, is this clear? Is this clear or not? Yeah. Okay, so this is how we can prepare carbonyl compounds from alkenes. Okay, this is clear. Next, hydration of alkynes. Just listen here, this is also important reaction, ma. See, alkyne, you take one alkyne, here I am taking CH3, C, triple bond CH I am taking. To this hydration, it means we need to add water right now. So addition of water takes place in presence of HgSO4, H2SO4 or water hydrolysis. Now what happens here is we just need to add water to this molecule. Okay, and here it will catalyze the reaction, just we are adding water. See, addition of water is nothing but we are adding one H plus and one OH minus ion. Only these two things we are adding now. Water is nothing but H plus and OH minus. So understand in a simple way, that's why I am saying H plus and OH minus. So now using these pi electrons of which is present between these two carbons, it will be accepting a proton. Okay, so once it is accepting this proton, this carbon will get positive charge now. Yeah, see again sir, why you are adding this hydrogen only on this carbon, why not on this? Yes, you can add on this also, but this carbon, if I place a positive charge, it's a unstable carbon, carbocation right now. So that's why I am placing positive charge on this carbon and hydrogen on the terminal carbon here. Okay, so you add H plus proton to this terminal carbon and create a positive charge on this internal side carbon. So there we can add this OH group, because this primary carbocation, this carbocation formed can be relatively more stable when I compare with this side. So that's why add OH here, hydrogen here. Okay, that's it. It means the carbonyl group, one of this carbon will be converts into carbonyl group. So which carbon is converting now? Yeah, so you need to decide based on the stability of carbocation formed. When we are removing this pi bond from between these two carbons, it should generate a more stable carbocation. Which carbon will be generating that? Yeah, this side is relatively more stable. So that's why I am adding OH onto this double bond, hydrogen onto this, like this. Okay, so this is enol now. So enol, we can do a keto-enol tautomerism. So what is this keto-enol tautomerism? Like 1,3 proton transfer we can do. Okay, so from here I am transferring proton from here to here. 1, 2, 3. So CH3 C, between carbon and oxygen double bond, and this pi bond is shifted onto the terminal carbon. We have 2 hydrogens, now one more we got. So CH3CO CH3. Yeah. So that is what the final answer. Acetone is your final answer for the reaction. Okay. Is this clear, guys? Is this clear or not? I hope this is clear. Right. Let's move forward. Next one is from acyl chlorides. Okay. How do we prepare carbonyl compounds? How do we prepare carbonyl compounds from acyl halides? That is, we can prepare using Rosenman reduction. What is this Rosenman reduction? Yeah. Remember, in Rosenman reduction, we will use a catalyst called Lindlar's catalyst. What we are using? Lindlar's catalyst. Okay, right. So, acyl chlorides, like this we have acyl chlorides. Upon treating with H2, PD, BaSO4 or PD, BaSO4, quinoline also taken. Okay, so now what happens? This hydrogen will be getting replacing this chlorine. Okay, so aldehyde is formed, respective aldehyde is formed. That's it. Okay, Rosenman reduction converts alkyl or acyl chlorides to aldehydes. Okay, catalyst used here is reagent or catalyst used here is Lindlar's catalyst. Okay, remember this. Okay, so the next one is Stefan's reduction. What is the Stefan's reduction? Alkyl nitriles or alkyl cyanides. Okay, so upon treating with SnCl to HCl. Okay, so what I am taking R C triple bond N. So this is treated with HCl in presence of SnCl2, gives you imines first. What it will gives you? Imines. R CH double bond NH. Okay, this is imine. Okay, so this imine will undergo hydrolysis, okay, and gives you final product as a C. If I remove this part, what we have? C R C H double bond O. So R C H double bond O, and this will be liberated as ammonia gas out. Okay, so we got an aldehydic group here. So cyanides converts into aldehydes using SnCl to HCl. Okay, this reduction is called, this conversion is called Stefan's reaction. Okay, so this is what? Stefan's reduction. Okay, next. Using dibol H, okay, alkyl nitriles and esters. See, dibol H is a diisobutyl aluminium hydride. Okay, so this will be converts alkyl nitriles to aldehydes. To what they will convert? Alkyl nitriles to aldehydes. Okay, alkyl nitriles are also esters. Both of them will be converts into respective aldehydes. Okay, right. So now let me give you one example here. Okay, so dibol H, so it will give you respective aldehyde. Same number of carbon should be there, that's it. Write the respective aldehydic product. It can be ester also. It can be any alkyl group. So this will convert into respective aldehydic group when I use dibol H. Okay, remember whatever we have discussed in last 10-15 minutes, like preparation of carbonyl compounds using different methods. Okay, all these are very, very important more. Okay, so from phenols to aldehyde. So what is that process? Phenol to salicylaldehyde we are using now. So that is called a Reamer-Teamer RTR reaction. Okay, so we discussed this in the alcohol chapter also. What it will do? Chloroform treated with phenol in presence of basic alkaline medium like NaOH. Okay, and this gives you salicylaldehydes, orthosalicylaldehyde and this para one, like this. But this is a major product due to hydrogen bonding. All this discussed These things are discussed even in the last class, in the yesterday's problems discussion of alcohols, phenols, ethers. I have explained about Reamer-Timmer reaction using PYQ questions, right? Yeah. So next here, yeah, chromyl chloride reaction here. Etards reaction we can say. What it will do? Alkyl benzenes. What it will do? Alkyl benzenes will be converted into aldehydes. Okay. Take alkyl benzenes like toluene I am taking. So toluene upon treating with CrO2Cl2, okay, CrO2Cl2 converts this methyl group to respective carbonyl compound like this CHO. Okay. So not only this, you can also remember one more concept here. Yeah. See, when we have an alkyl group on the benzene ring, this terminal, this last methyl group is there now, that converts into respective aldehydic group, CH2CHO. This is what you need to remember here. Okay. So oxidation of toluene to benzaldehyde. Yes, you have seen this. Okay. Right. So what is that compound called? Chromyl chloride. Chromyl chloride converts aldehyde methyl benzenes to or alkyl benzenes to respective aldehydes like this. Okay, like methyl benzene to benzaldehyde. Okay, that is the example to be remembered. Okay, so that's it about Etards oxidation. Next, Gutterman-Koch reaction. So what is this Gutterman-Koch reaction? Benzene reacts with carbonyl group and in presence of HCl, like CO plus HCl you need to take in presence of AlCl3 anhydrous form. Okay, or you can also use CuCl. So gives you respect to benzaldehyde, like aldehydic product. See, this carbonyl group and this hydrogen, you can form a product like this. Okay, right. So yeah. So the next one is preparation of ketones. Till now we have seen aldehyde preparation methods. Till now we have seen aldehyde preparation method. Now we will be discussing about ketones preparation methods here. Okay. So first one is from acyl chlorides. From where? Acyl chlorides. See, acyl chloride with dialkyl cadmium. With what? Dialkyl cadmium. So this alkyl group will be added to this carbonyl group carbon by removing chlorine. So RCOR will get. Okay. This is a ketone product is produced here. So from Grignard reagent we can use RMGX plus alkyl cyanides gives you first imines upon hydrolysis gives you carbonyl groups. Okay, I will tell you here, no worries. See, RCOCl is there. So this is acyl chlorides now. So we are adding dialkyl cadmium. Okay, like an organometallic compound you can consider it as. Okay, so now what happened? This chloride ion goes out and this alkyl group comes as a nucleophile and gives you RCO, R dash kind of ketones as a product. Okay, remember this. Okay, the next one from Grignard reagent. Okay, I am taking alkyl cyanides with RMGX. RMGX is Grignard reagent. Okay, now what this Grignard reagent will do? So Grignard reagent example, let us take one example here. Methyl magnesium bromide or chloride you take. Methyl magnesium bromide I am taking. So this is an example of Grignard reagent. Now methyl, see, magnesium will be positive charge +2. Bromide will be -1. So it means methyl should also have -1, therefore overall molecule become neutral now. So our methyl is having negative charge, it means it's a nucleophile now. So this methyl group will attack on this carbon of this nitrile, of this cyanide, okay, and this bond will be shifting towards nitrogen side. Then you will get a imine salt like this. Like this we will get a imine salt right now. So these imine salts upon hydrolysis, what we are doing? Adding water, okay, gives you respective ketone product like RC double bond O CH3. Okay, this is how you need to perform the reaction. Okay, right. Next one is from benzene. Okay, so how do we do this from benzene or substituted benzenes? It is simply aromatic electrophilic substitution reactions. See, COCl is there. So here Cl is there, so I am using anhydrous FeCl3. Now this FeCl3 and this Cl will be removed, so we will get an acyl carbocation like this. Okay, so this acyl carbocation is an electrophile, right? So that will be attacked by this benzene pi electrons to give you a complex like this, a sigma complex, a carbocation like this. Okay, after deprotonation we will get we got a ketone now. So after deprotonation we got a alkyl group is there, aryl group is there, C double bond O. So it's a ketone. Okay, right. So this is how we can prepare. So what is the name of this final reaction, last reaction? Friedel-Crafts acylation. What is the name? Friedel-Crafts acylation is the name of this last reaction. Okay, right. Now we have to discuss about this one, nucleophilic addition reactions. Okay, so these chemical properties of aldehydes, ketones, carboxylic acids will be discussed in the upcoming session. Okay, in the next session we are going to discuss about nucleophilic addition reactions. Guys, I hope you really followed the session completely till now, whatever we discussed. Yeah, so once after completing this session, just go through your notes, whatever you have made or screenshot, whatever you have taken. Okay, so that you will get complete quick revision. Okay, after that you just see few questions related to this topic. Okay, and after that you just go to the yesterday's session, that questions discussion on, that is what, alcohols, phenols, ethers, part 4. Yes, you can watch it. I have solved many questions in that which are very important from alcohols, phenols, ethers, and also some miscellaneous concepts of organic chemistry. Okay, right. I hope you really liked this session. If you are new to this channel, click on the follow button and you can share with your friends. Thank you for watching. Stay connected. Thank you.